Okay, so we're going through all these measures of central tendency, standard deviation, variance, what a normal distribution is, and then we're going to go down and do all of this stuff and whatever. So it goes without saying, this is probably the easiest part. Mean, median, mode. The mean is the number that's, it's the average of everything. The median is the number in the dead center, and the mode is the most recurring number. So just a few little trick cases here. What do you do when, you've got a set of data like 1, 2, 3, 4, and you're looking for the median? Well, typically for the median, you cross out the edges, and then you wait until you have just one, left. But here you got 2 left. What do? Well, you just take the average of these 2. So it would be 2.5 would be the median in this case. All right. All right. And then how things are dispersed. Standard deviation. Standard deviation tells you how much variability, how much variance also, though statisticians might get upset at me saying that. How much variability do you have in your set of data that's, located around the mean? So I can have a group of people distributed like this, and let's just say I'm looking at, this is a distribution of someone's age, okay, and here's the mean, okay. Of course, you'd have the mean, the median, and the mode all being the same. We're living in a perfect world here. And here you can have a good idea of how much variation you have in your set of data. What if I told you that you could also have your age distributed in a group, but it's distributed like this? Well, you'd say in this second example, that I have right here, that, well, here the standard deviation isn't large. It doesn't, vary as much around its mean. And you'd be right. You'd be completely correct. It doesn't vary as much around the mean. Okay. So let's just to give you an idea of how standard deviations can be different with different populations, different samples, different whatever. Okay. I haven't really seen too many questions about, variance equals the square of the standard deviation. But you do see things that come up with the standard error. And what this is, it tells you how much variability do you have in your, theoretical mean compared to, the true population mean. And you can already kind of guess that, well, if I only have, 2 or 3 data points, I'm not going to be doing so hot when I guess, the actual mean. But if I have, a billion sets of data, a billion, points that I can test, then I'll probably get really close to the actual mean. And so that's what they mean here when they say the standard error decreases as the number in your sample increases. Okay, let's go here to a normal distribution. A normal distribution just refers to this bell-shaped curve, all right? And when you have a normal distribution and when you have normally distributed data, typically you would have the mean equal to the median equal to the mode. Okay. So let's talk about these numbers here, because this is where you're going to get tripped up. And they love asking questions about this, because I've seen it on all my exams. So let's go right here. So this little 1 and then the Greek symbol, it just talks about 1 standard deviation. And for the positive, it means above the mean. And right here, this is 1 standard deviation below the mean. And before jumping into these numbers I have here, and this 99 and 97, blah, 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 let's just try and visualize in our head what a standard deviation is. Like, why is it important? Who cares? Well, a standard deviation is going to group data in something that is a significant way. You could think of the mean is, of course, the average. And what does it mean to be 1 standard deviation or 2 standard deviations above the mean? Or below the mean? And what it means is that if you're 1 standard deviation above or below something, it's a notable, significant, sometimes you can see the difference. So I like using the example of athleticism or something, right? Let's say at 1 standard, or let's say your mean is someone like you, someone like me, a normally athletic person, okay? And we'll say that that 1 standard deviation, someone who's notably different, this was the the really good high school athlete, let's say, right? This was the person who was captain of the track team or whatever, and blazing through the hurdles and whatever. Okay, and there's a notable difference between that person and your typical run-of-the-mill Joe Blow. Okay, and we'll say 2 standard deviations. Okay, the difference between 2 standard deviations above the mean and 1 standard deviation, 1 standard deviation above the mean, is the same difference, kind of, in your mind, between that one person who was so great compared to your average Joe. Well, to someone 2 standard deviations above the mean, this 1 standard deviation above the mean will look a lot like we looked to them. So if someone 1 standard deviation above the mean is your super pro high school, athlete, then your person 2 standard deviations above the mean will say is your college athlete, And just like a normal person would look puny compared to your, 1 standard deviation person, let's say. Well, a 1 standard deviation person looks puny to a 2 standard deviation person. So we'll just call this a college athlete. And 3 standard deviations above the mean means that, again, it's a notable step, notably different from someone at this particular level, 2 standard deviations above, and notably different from someone 1 standard deviation above, and notably different from your normal run-of-the-mill Joe Sixpack. So this, you could say, if we're still using our athletics association, if we're using our athletics example, then we would say, well, this is your professional athlete. Okay, this person is 3 standard deviations above the mean. And if you want to go nuts, you can say, well, you can go even higher up, and we're talking about, people in not just professional athletes playing in basketball in Europe or something, or in the D League. These are the NBA players up here, and way over here is like LeBron James or something. But the same goes, for being above the standard deviation as being below. It's a notable difference. Someone will perform notably different at 1 standard deviation below the mean than they would if they were at the mean. So if we're still using, athleticism, we'll say this is your normal guy, and this is the person who's always picked last, and here's the person who, has trouble just moving around in general, and 3 standard deviations below the mean is someone who's like bedbound or something. All right, but enough about that. Okay. Let's talk about these numbers here. So 68%, what does that mean? Well, 68% refers to the percent of people within 1 standard deviation. So that means within 1 standard deviation above the mean and below the mean, which we have represented right here. 34 plus 34, 68. 95% is the amount of people within 2 standard deviations of the mean. Okay, and that's because, well, when you go up 1 standard deviation, you go up 34%. When you go up a 2nd standard deviation, it's around 13%. It's really like 13.5 or something. And then when you go up an extra standard deviation from 2 standard deviations to 3, you go up, it's like 2.1% or something. It's around 2%. Around 2. Man, I wish I could draw well. It's around 2. Very nice. It's around 2%. Okay, so where are they going to trip you up? They love these questions. They love it because they know that kids think, wow, 95%, that's 2 standard deviations. So someone who's 2 standard deviations above is at the 95th percentile, and that's how you lose points. Because 95% just means how much of the total population do you have within, plus or minus, 2 standard deviations of the mean. Someone who's actually 2 standard deviations above the mean is at the 97th percentile, because remember, 1 standard deviation above the mean is 34%. Here's 34 plus 34, 68. And someone 2 standard deviations above the mean is 13% above that. So 13% above 84, again, it's roughly 13, will be 97. Okay, all right. Just making sure you're paying attention. They'll get you with this. All right, let's see what's next. Bimodal distributions. I mean, the only thing that's important to understand here is just kind of see what it looks like. And this is good because you keep seeing this all the time, not just step 1, but also step 2. Hodgkin's lymphoma, you keep seeing this bimodal distribution. I won't talk about this because this is kind of sad. Okay, let's talk about skews. Alrighty then. Well, we have a normally distributed set of data right here, right? Mean equals median equals the mode. Yeah, but what happens if someone introduces a piece of data that's just so incredible, right? That now everything kind of gets shoved a little bit this way, towards the right, because it just messes everything up. You know, it's like, we had our population and we were looking at the heights, and then, oh my God, Shaquille O'Neal came in and just messed everything up. You know, this would be a positive skew. And they'll tell you down there how, and when you skew data, the mode doesn't change, the median changes a little bit, and the mean will actually be the thing that changes the most. Well, let's see how true that is. Okay, let's just run a test. You know, the best way to check for the validity of an idea is through experiment, according to Dick Feynman. So let's check it out. So we have a normal set. Well, it's not normally distributed, but let's just say we have a set of data here: 1, 2, 3, 4. Okay, and all right, what's our mode? Well, here there's no mode, but let's just say there was another 3 here. Okay, well then that would be the mode. All right, great. But now let's look at the mean and the median. Okay, so the median here is, well, take out 1, take out 4, take the average of 2 and 3. The median is going to be 2.5. Okay, all right, cool. Well, what's the average? Well, 1 plus 2 is 3, plus 3 is 6, plus 4 is 10, divided by 4 is also 2.5. Okay, very nice, very nice, very nice. All right, but now we're going to have a positive skew, right? Because we add, you know, data that's going to shift everything to the right. What happens when we add this 10? Well, does the mode change? Well, no, the mode doesn't change at all. Does the median change? Well, let's see. Okay, 1, 10, we cross up the 2, cross up the 4. The new median is 3. Well, it used to be 2.5, okay? So it changed, yeah, by 0.5. Okay, not bad, not bad, not bad. But let's see how the mean changes, okay? Okay, so we have 1 plus 2, 3, 6, 10, 20. Whoa. 20, and we have 1, 2, 3, 4, 5 variables. So now the new mean is 4. Whoa, this changed by 1.5. Remember, the old mean was 2.5. So the mean changed by 1.5. The median changed by 0.5. And the mode, well, didn't change at all. And that's actually what you're going to see in, in the book and in real life, you know. Mode doesn't really change, median changes, you know, a little bit, and the mean changes the most. And this goes for if you have a positive or negative skew. You know, in our positive skew, everything kind of gets zipped, pulled a little bit here, and in a negative skew, everything gets kind of zipped, pulled over here because of this, you know, incredible negative value. Okay, and then finally we have the null and the alternative hypothesis. So this is probably the most important thing to get your head wrapped around, which is conveniently also the easiest thing to get your head wrapped around in this biostats chapter. The null hypothesis just says, oh, there's no correlation. There's no relationship between these two things. All right, so for example, if we're trying to study how much you smoke and how early you get cancer, the null hypothesis would say, oh, there's no relationship between smoking amount and cancer onset. And the alternative hypothesis is the opposite, which of course you could have gathered by looking at this binary 0-1 term here. But the alternative hypothesis in our cancer and lung cancer and smoking example, it would be, no, there is a relationship between, you know, how much you smoke and the age that you get cancer. There is. All right, so there we go. Null hypothesis says, oh, there is no relationship. All right, guys. Don't get fooled by this. Remember, 1 standard deviation, 84th percentile. 2 standard deviations, roughly 97th percentile. But 2 standard deviations within the mean is 95% of the people.